On the packet. Questions? 30? Problem 30. Problem 30. I'm not going to try to draw this figure up here. On problem 30, let's do volume first because it's easier. All right. What shapes do we have to find the volume of that picture?
Rectangular prism.
A rectangular prism and a triangular prism. Good. So a rectangular prism, and all we're going to do with them is add them, plus the triangular prism. How do we find the volume of a rectangular prism? Look up on your formulas packet. If you don't remember it, this is the one you should remember though. What's the formula for a rectangular prism?
For a volume.
Volume.
Base. Like the surface area.
Length times width times height. That's the easy one, right? Now for a triangular prism, what's the formula for volume? For any other prism, what was the formula?
Big B times H.
Big B times H. All right? Remember, is this H and this H the same thing?
Yes.
No. So don't get the things confused. Got all kinds of H's and B's and everything, R's and all these, and they all mean something different for each different formula. For the rectangular prism, what's the length and width and height of the rectangular prism?
6, 11, 7.
Does it really matter which one's which? Makes no difference. Now, for the triangular prism, which one's a base? Which face on that is a base?
For what? The triangle?
Triangular prism.
Triangle.
The triangle. So we got the triangle, it looks something like this. That's 7, that's 9. They tell us that this height is 4, and this bottom is 11. Which ones do we need to find the area of that triangle?
4 and 11.
To 4 and 11. Remember, formula for area of a triangle is 1/2 times base times height. Have your calculators out, help me here. So that's 0.5. We'll just do decimal form. What's the base? 11. What's the height?
4.
4.
484.
22.
Oh, you have to do that. Never mind. I get the whole thing.
All right, so that's 22.
I added them up right there. Six
Somebody do
times
this part
11.
for me.
That's what I did.
6 times. 462.
462. And what's our total?
484.
484. What's our units? When we take this test next class and you're doing your units, can Silas at least get that part right on every problem?
Yeah.
I'm hoping. If it's volume, it's always cubic units. What was the units this time? Meters to the third. So at least make sure you get that part right on every single problem. Now for surface area. Surface area a little tougher on this one. Anybody tell me why surface area is going to be a little tougher?
The triangle.
Yeah, sort of. What part's not on the surface?
Bottom.
The bottom of the triangular prism and the top of the rectangular prism. So we're going to have to get rid of that in both of them when we do surface area. All right, because it's not a surface part. It's not on the surface. Just the stuff that you can touch on the outside is the surface. So when we do the when we do the rectangular prism, how many faces are we actually going to have?
5.
5. Instead of 6, we're going to have 5. So I'm just going to draw, what are all those faces in that rectangular prism?
Rectangle.
Rectangles. So I'm going to draw 5 rectangles. Let's do the front face right here. What's the dimensions on it? 6 and 11. So let's write that in. Let's do this side over here. What's the dimensions on it? 7 and which one is it? 6 or 11? 6. If we do the back side, or the side that we can't see, over on the left, what's it? Same thing. 6 and 7. We did the front, what's the back that we can't see? 6 and 11. And then we have the bottom. What's the dimensions of the bottom?
7 and 11.
So you got to be able to find those, and you got to be able to split them all off. Now again, we only have 5 here because we don't have the top. It's not part of the surface. It's not outside where we can touch it on the outside of the shape. What's the area of this part?
66.
66. You just multiply length times width, right? How about this part?
66.
66. This one? 42. This one?
42.
42. This one?
77.
77. Here in a second, we're going to add all those up. Before we do that, let's do the triangular prism. What kind of faces are we going to have on the triangular prism?
2 triangles.
The 2 triangles and
2 rectangles.
2 rectangles. How come not 3 rectangles this time?
Bottom.
Because you got the bottom that's not part of the surface. All right? On the triangles, didn't we already find the area of the triangles?
22.
There's 22 right here, right? So let's just fill it in. That's 22, that's 22. We found it up here when we were doing
But don't show another rectangle.
volume.
Or whichever rectangle it is.
No, because these are different rectangles for this top part.
Wait, how did you get the 2 rectangles with the triangle?
Because
Never mind, never mind.
in a rectangular, or I'm sorry, in a triangular prism, if I have this triangular prism right here, you got 2 triangles as your bases, right? Those are your bases. Remember, these are your bases, not this. These are your bases. And then how many rectangles do we have? 3 of them. But on this, we have it set like this. Can I touch that bottom face? So it's not part of the surface area. It's got to be taken away. So we have this rectangle. On the rectangles, what's the rectangle on the right-hand side? What's the dimensions of it?
9 and 11. 7.
What is it?
Oh wait. 6 and 7.
I don't think the 6 is it?
9.
9 and 7. 9 and 7. Make sure you pick that out. This part right here is 9. This part going this way is 7. What's the dimensions on the back rectangle?
7.
7 and 7. What is 9 times 7?
63.
63. Good. What's 7 times 7?
49.
49. What are we going to do with all of these?
Add them all up.
Add them all up. So somebody do that for me as soon as I get out of the way here. We want to add all those up. More than one person be doing it, because if we get the wrong answer, then you got the wrong answer on your paper.
About 405. Okay.
Something else I want to say, next week I think we got the math test, right? So next week, please make sure you bring your own calculators. I would suggest, and I've been suggesting all year long, and I don't see any of them that you have in here, but I would suggest a TI-83 or 84.
I got one of those up home.
Don't use their calculator on the thing. It's a pain in the butt, and I'm not going to explain it to you because I don't like it. Bring your own calculator.
I still keep getting 409.
I'm getting 449.
449 or 4?
Oh, I forgot to add the 22 plus 22.
449?
Yes.
Is that what we're going with?
4.
449. What's our units?
Meters.
Meters. Just meters?
Meters.
Remember, anytime it's area, even if it's surface area, it's still square units. So meters squared. Volume's always cubic units. Perimeter, perimeter and circumference always just regular units, and any kind of area, surface area, or whatever area it is always square units.
Number 3.
Is there tests? Is there 2 parts to it?
Yeah, I think so.
Dang. Is there 2 parts to every test?
Yeah. Which one, Bobby? 3? Problem 3. Problem 3. Somebody tell me what kind of shape we have in problem 3.
It's a pentagon.
It's
Pentagonal prism. If we're going to do, let's do surface area first. For surface area, what shapes am I finding the area of?
Pentagon.
How many pentagons? 2 pentagons. What do we know about those 2 pentagons? They're going to be the same here, right? And they also, we need 5 rectangles. Now, if this is, it looks like it's a regular pentagon, right? And apparently it is, because that's all the information they told us. So it's a regular pentagon. So what do I know about all 5 of these rectangles? They're all the same. So if we find one of them, we can just multiply that by 5 instead of finding them all separate. That only works if it's a regular pentagon or hexagon or octagon. What's the formula to find the area of these pentagons? Look it up on your formulas worksheet. For a pentagon, a regular polygon.
Surface area?
For area of a regular polygon. 1/2 times P times A. You got to remember this formula. If you don't have that formula memorized by now, 1/2 times P times A. What's the P stand for? Perimeter. What's the A stand for? Apothem. So we got to find the area of those two. We're probably going to change that 1/2 into a 0.5 times the perimeter. How are we going to find the perimeter of this pentagon?
Add up all sides.
Add up all the sides. So what is that?
4 plus 4 plus 4 plus 4.
It's 20.
It's 4 times 5, right? So it's 20. That's the perimeter of that pentagon. And then what's the apothem?
2.75.
2.75. Remember the apothem goes from midpoint of one of the sides to the center. What's this other thing called? Radius. All right, that's a radius. That's an apothem. We don't need the radius this time. Somebody do all that stuff for me. 27.5. So that one's 27.5. What's this one over here? 27.5. Now the rectangles. Figure out what's the dimensions of one of the rectangles.
4 centimeters?
4 by 18. And that's going to be all of them, right? What is 4 times 18? 72. What's the area of this one then?
72.
This one?
72. 72.
Now is it always going to be that way?
No.
No, only if the base is regular.
It equals 360.
So all of this totals up to 360?
No, not the
No.
27.5.
So we need it all.
415.
415. What's our units? Centimeters squared. That's for surface area. Now let's do the volume. How do we find the volume? What's the formula for volume of a pentagonal prism? Big B times H, right? Big B times H. Which face is the base this time? The pentagon. Well, we already know the area of it, don't we? We already found it. So what goes in place of big B right here? 27.5. Now watch closely on this. Make sure you don't forget this. If you have your pentagons, I'm just going to add it onto this one. You have your pentagons. Pentagon. Mine looks horrible, but oh well. That's supposed to be your pentagon. Where do you find the height of this pentagonal? Where do you find the height of the prism? It's the one that connects the 2 bases. That's your height. Not this. This is your height. The distance between the 2
Because you guys said it.
bases. All right? So it's always this distance. So what's the height of our prism going to be this time? 18. Make sure you don't forget that. That's where most people get the most confused at with volume. What's that give us? 495? What's our units? Centimeters cubed. Again, if nothing else on this, if this problem's on the test next class, it's worth 4 points. You should be able to get how many points at least? 2. Should anybody miss that right there? No. Surface area is going to be, you look at the paper and it says all centimeters. So for surface area, centimeters squared. For volume, centimeters cubed. You should probably be able to go down through on your test and just write down all the units right off the bat, right? And get all those points. And that's all that's going to be on this test, well, almost all. That's all that's going to be on this test, so you should be able to get what grade at least? Well, you should be able to, but 50% at least, right?
Yeah.
Even with our friends that lay their head down all the time.
You say it like
No,
it's
no,
on
I need
paper.
20 minutes.
Should we get a piece of paper?
Yeah.
Your formulas packet.
The packet? Can I draw on it?
Yeah, you already wrote notes and stuff on it, and we're gonna write some more on it today. Next question.
11.
Notice I ignored Bobby because it drives me nuts. She's completely lost, isn't
She
she?
doesn't even know.
Completely lost. She doesn't even remember what she said half the time. That's
She's
it.
gonna get so angry and she doesn't even know what he's talking about. What?
What kind of shape do we have? Close. Trapezoidal prism. It's a trapezoidal prism. Mine looks not very good. So it's a trapezoidal prism. We're doing surface area. What faces do we have? How many trapezoids? 2 trapezoids. Have that formula's worksheet out again unless you remember the formula. What other faces do we have?
4
4 what?
rectangles.
Rectangles. Shh. Back on track and listening. 4 rectangles.
Oh, I got the trapezoid.
So for the trapezoid, what's the formula for area of a trapezoid?
It's half height, parentheses, B1, B2.
B1 plus B2, right?
Yeah.
We fill in these numbers, they give us something in here, that's an altitude, they tell us that that's 4, this is 3, this down here, this side is 11, they tell us this side over here is 4, they tell us that this side right here is 6. For just the trapezoid, we need the height and the 2 bases. We'll probably change that to 0.5, what's the height? 4, what's the 2 bases?
3, 11.
Remember, it's the 2 that are parallel to each other, so 3 plus 11. Somebody do all that for us. What's the area of that trapezoid?
I got 28.
28. Anybody else get 28?
Yep.
So the area of that trapezoid is 28. What's the area of the trapezoid on the back?
28.
28. Now we just got to do the rectangles. Let's do the bottom first. What's the dimensions of the bottom?
4 and 11.
4 and 11. You got to be able to pick that out. Trace it.
44.
All right, that's 44 area. We can do it as we go, I guess. Be careful here. What's the area of this rectangle? Or I'm sorry, what's the length and width of that rectangle?
4 and 6.
4 and 6, good.
24.
That's 24. How about the one on the other end?
4 and 6.
4 and 6.
24.
So that's also 24. And then the only other rectangle we need is the top. What's the dimensions of it?
3 and
3 and 4. Everybody agree with that?
Yep.
What's the area of that?
12.
What do we do with all that?
I don't know.
Add them all up. Somebody do all that for us. What is it? 160? What's our unit? Inches squared. Everybody agree with that? How do we find the volume? What's the formula for volume of a trapezoidal prism?
Base,
Big B,
height. Height.
what's that? For the big B, we already found the big B. That's the trapezoid, right? So it's 28, that's the area of the, one of the bases, times,
4.
stop and think for 1 minute, how do you find the height of a prism?
So
Oh, you lay it on its side and go up.
So what is it?
4.
So it's this right here, right? It's the distance between this base, that trapezoid, and the other trapezoid. It's that distance. Gotta be able to find that. Hunter realizes, hey, he keeps going over and over and over that. I wonder why. Because of teaching for 20-some years, where do I know most people are going to make a mistake on this? That height. They're going to take, now they get lucky on this one. because they're gonna take this height, well what? That ends up being the same for this one, I probably won't be that generous on the test, right? What's 28 times 4?
112.
112, anybody else get that?
Yeah.
What's our units? What's volume mean again? How much will go inside this trapezoidal prism? Surface area is what?
Outside.
The outside, how much we can actually touch if it's a solid shape, alright? So, for something like this triangular prism, volume would be how much wood it took to make this. And surface area would be how much it would take, how much marker it would take for me to color it all in. One more question.
30.
Which one?
Yes,
31? 31? 31. Let's do volume first on this one. Because volume's easy. What kind of shapes do we have?
Two rectangular.
A rectangular prism and a rectangular prism. So for volume, all we're going to do is add those two together and get the total volume. Do we have to worry about subtracting off anything? No, because you're just finding volume of both of them. So we're just going to add them together. Let's do the bottom one first. What's the formula for a rectangular prism for volume? It's an easy one again. Length times width times height. For the bottom rectangular prism, what's the length, what's the width, what's the height?
14, 9,
14 times
15.
9 times, is that right?
15.
15? 15 times 9 times what?
4.
4. Plus, for the top rectangular prism,
5 times 5 times
5 times 5 times what?
9.
9. Somebody do all that math for us.
I got 765.
Anybody else get that? Before I write it down. 700 and what? 65. What's our units? Millimeters cubed. That's how much volume it has, how much will fit inside that whole shape. Then surface area. Surface area, not real hard on surface area, except, what do you have to remember on this one?
Take off the bottom.
You gotta take out the bottom of that top shape, right? And not only do you have to take it out of the top shape, but you also have to take it out of the bottom rectangular prism because neither one of them's on the surface. So let's find the top surface area of the top one first. How many faces are we going to have in the top one? 5. 1, 2, 3, 4, 5. Now I'm going to do this. I'm going to put that 6th one in there, but we're going to end up getting rid of it. All right? But we still want to find it because we have to take that away from the bottom one also. Okay? So give me dimensions. What's the dimension of the very top of the top rectangular prism? 5 by 9.
45.
And then that means the bottom, this one here that we're getting rid of, is also what?
5 times 9.
5 times 9, which is 45. That's 45. Don't forget, this is the one we're going to get rid of, so we're not actually going to add it in. What's the dimensions of this space right here? 5 by 9 again. That's 45. What's the dimensions of the back face, or the face on the left over here that we can't see? 5 times 9, which is 45 again. What's the dimensions of
5 by 5.
the front littler face? 5 by 5. What's that give us?
25.
What's the back little face that we can't see then? 5 by 5, which is 25. So that's all of the top. Now the bottom, how many faces are we going to have on the bottom?
6.
We're still gonna have 6, aren't we? But one of those faces, we're gonna have to do what? Minus off, how much?
45.
45. We're gonna minus off this 45. Let's just put it on this one right here. We'll say from that face, we're gonna subtract off 45 because we got this shape sitting on top of that shape, and we're getting rid of that part because it's covering it up. Okay?
15 times.
Let's do the bottom first. What's the dimensions of the very bottom? 15 and 9,
135.
135. What's the dimensions of the top then?
15 times 9, 135.
But that's the one that we're gonna subtract off that 45 from, right?
90.
So that's 90. So that's gonna be our other area there. Let's get rid of that. We're gonna have to add that in. What's the dimensions of this front face right here?
4 and 9. 15 and 4.
15 and 4. What's the dimensions of the back face that we can't see then? 15 and 4.
60.
60 and 60. What's the dimensions of this side over here?
9 and 4.
9 and 4.
36.
36. And what's the dimensions of the other one then? 9 and 4, which is 36. What are we gonna do with all of these and that 90?
Add them together.
Add them up. Remember, you're not gonna add in that 135, but you're gonna replace it with the 90. Add in all these, and that. Make sure we got more than one person doing this because it probably is somebody gonna mess up on this one. Yeah, probably. We do know our units. What can we put our units in as? Millimeters squared.
Yeah, 602.
602? Is that what we're going with?
Yay.
Oh, versus I can fit more into the shape than the actual size of it.
Do what now?
I can fit more into the shape than with like.
Because it depends on what shape it is. When you have things that are, like when you're building a house, the best shape for a house, which one of these two would be the best shape for a house? So if you wanted more living space, cube is. But most houses aren't cubes because what?
A lot of wasted space.
Not so much wasted space in the top, but it just doesn't look right. Most of you're used to seeing houses as rectangular prisms, right? But for the most living area, you're better off to build a cube. That's old houses. If you look at all these old farmhouses and stuff, they're cubed. They're not cubed, really, but the bottom is a square, and then they go up higher, right? 2 and 3 stories, but the bottom is more of a square. Now most houses are long and not as wide, and they're rectangular on the bottom. But these, that's why people back, 100 years ago built that kind of house instead of a rectangular prism, because you could get more living space out of this one. And that's why, so on stuff like this, you can, why you can fit more in out of a cube, because let's just compare like a rectangle. If we had a rectangle that was, let's say 7 by 5, and then we have a cube. If let's not do 7 and 5. Let's do. Trying to get something here that's basically the same. It's not that you have more living space. It's just it's better set up. Does that make sense? So if we tried to make these two where they had the same area, if this was the base of our house, and let's get rid of this, get rid of that, and we said that this one is 20 whatever squared, 20 feet squared, and we want this one to be 20 feet squared. we could do, on this one, we could do like 5 and 4 on that rectangle. On this one, it's gotta be, it's got to be the square root of 20. Somebody help me out, what's square root of 20 on your calculator? What is it?
4.47.
So about 4.5. You see how you're a little smaller here, and you're sort of getting more out of it that way. So if your property is a certain thing, you can get more by making a square. All right, get out the formulas packet. On the formulas packet, look at the last 2 pages. We're going to go over surface area and volume of cylinders, cones, pyramids, and spheres. I would probably say this is probably the hardest of all the stuff. But it's not really hard because every one of them has a formula. Except for the pyramids. Not all those have formulas. So on this, Sam was saying that he's got his land there. He wants to write more on it because he knows he can use it on the test.
It's a lot of packets.
So we're looking at, if you look at these 2 pages, this for surface area, and then on the back of that page, I got all these boxes here for the volumes formula. This is probably the hardest just because of the formulas, but the formulas also make it easier because what's going to do all your work for you when you have formulas? The calculator is going to do all the work. All you got to do is plug in, hey, I know H this time is this, I know S is this, I know R is this, and you just put in those numbers and let the calculator do all the work. So, surface area and volumes of cylinders, cones, pyramids, and spheres.
What's this packet?
Remind me at the end. I'll collect those back and remind me. Well, you know what? No, I think we're going to keep them. Maybe I'll just let you use those on the test next time too. Find the cylinder surface area and volume. Find the cylinder surface area and volume. One's on one page, one's on the other page. So find them, be looking at them. For surface area of a cylinder. Everybody find that one. It's right here, right? You might want to write some stuff in here. That's up to you. I'm not going to beg you to write stuff in. I would highly suggest that you write stuff in. On this formula, for the surface area one, what's the R stand for?
Radius.
Radius. That's the radius.
Yep, right.
So that's the radius. And that radius is given on the base of the cylinder. When you have a cylinder, what kind of shapes do you have in a cylinder?
A circle and
2 circles and
a continuing.
anybody know what the other shape is?
It's a rectangle.
See if I have a cylinder here.
That keeps on
I
going.
used to have a cylinder. Probably got.
Yep.
I think one of my things got ripped off. That's my cylinder.
Yep.
You took a pop can and you cut it all apart and laid it out all flat. what would it look like?
Rectangle.
2 circles and a rectangle. 2 circles and a rectangle. Alright? So, when you're looking at surface area, what you're finding is you're finding the area of 2 circles and a rectangle. This part right here is for the rectangle. So you might want to write that down. That's the part that gives you the area of the rectangle. 2 times pi times radius times height. The height's always going to be right here on a cylinder. That's the rectangle part. So we got the 2 circles. This is our rectangle. That first part of that formula is this part, all the rectangle part there. This is the what part?
2 circles.
That's the 2 circles. Now the reason this is important, because a lot of times, let's say this is a cup. What's it not going to have? It's not going to have that top. Alright? Because it's going to be open there. So if we're trying to find the surface area of this cup, we're not going to have 2 circles. How many circles are we going to have?
1.
Just 1. Guess what you do to this part of the formula if you only want 1 of those circles?
Take it out.
You just get rid of that 2. So if you just wanted 1 circle, you just get rid of that 2 right there. Alright? Just get rid of that 2. Does anybody remember this formula? It's the area of a circle, isn't it? So that's why we got 2 times that, because we have 2 circles. If you only want 1 of the circles, like let's say you got an above ground swimming pool. You got an above ground swimming pool. It's going to look something like that, if I could draw it. What does it not have? It doesn't have that top. Right? So you're getting rid of 1 of the circles. So make sure you can, sort of think about that, because a lot of times we won't want that top. If you got some kind of bucket, all right, and you're going to fill that bucket with something, you don't have a top. Otherwise, you can't put anything in it. You might put a top on it after you're done, but when you start off with the bucket, it doesn't have a top on it. So you'd want to get rid of that. Go to Lowe's and buy one of their buckets, they usually don't have the tops with them. The volume. How much wood it takes to make my cylinder here, that's the volume. It's just pi times radius squared. Anybody ever seen that formula before? That's the area of a, we just talked about it, right? That's the area of the circle. All you're doing is you're finding the area of this circle. That's the base of the cylinder. If you want to, maybe that confuses Hunter that that's the base up there. Well, then he could make that one the base. Does it matter which one of those 2 is the base? Same thing. And all you do is times it by the height of the entire cylinder. So don't make this harder than it is. The only thing hard here, you got to remember, oh, I forgot this. What does the H stand for? Height. I didn't write it in. Height. Sorry, I spelled height wrong there. So all you're doing is plugging in there. You plug in and you write it down. Let's put some numbers here. Let's say this is 12 and the radius is 5. And I want to find the surface area. You're going to write it out just like this. Surface area equals 2 times pi. What's the radius? Times what's the height? Plus 2 times pi. What's the radius?
5 squared.
You punch all of that right into your calculator, except for if you have a calculator like this one, you can't do it. This one you got to do it little part by little part. All right, so you just have to find what you'd have to do on this calculator, do all this, then do all that, write them both down and add them together. Okay, But if your calculator prints across the screen, you can type all that right into the calculator just like that and hit equals at the end. It'll give you the final answer. Okay? For a sphere, find a sphere on here. Sphere's right here for surface area. And then for volume, it's the very last one on the last page. Anybody ever seen this formula before?
Pi r squared, or?
That's the area of a circle. So if I took a sphere, a baseball or a softball, and I cut it all up, this is telling us that it's going to make how many circles? Four of them. If you took the cover off a baseball or a softball and laid it all out flat, you'd have 4 perfect circles, all the same size. All right? So all surface area for a sphere is 4 times pi times radius squared.
Wait, how does it make 4 perfect?
I don't know, go home and figure it out tonight. But that's what the formula tells us. All right. For volume, looking at volume, a little different. On this one, what I would probably do, and you might want to write this down on there, for volume, I might change this formula to this. 4 times pi times radius to the third divided by 3. Punch all that into your calculator, all the top, hit equals, and then just hit divided by 3, and that'll give you your final answer. That might be better than dealing with the 4/3. What if I have something like this? Instead of a whole sphere, I have a half a sphere, which is called a, what's half the earth called? Hemisphere. Right? So you have a hemisphere. If you're doing hemisphere and you're doing volume, you would just take this whole thing and divide it by 2. What about surface area? Would you just take this and divide it by 2? It's a little different on surface area. Watch this, because this one is a little confusing.
Because you gotta have the bottom.
So we got this and we want the surface area. And Ian's right. We still got half the sphere, right? So we're going to take this and divide it by 2, but then we have to add on what? The bottom, which is a circle. So if we were to find the surface area, of a hemisphere, we would have to take 4 times pi times radius squared and divide that by 2. But then we would want to add on the area of the circle. What's the formula for area of a circle?
Pi r squared.
Pi r squared. So we'd have to add on that pi r squared.
What's the base of the sphere?
But it doesn't have a base. So just remember, if you have a sphere and it's cut in half and you're trying to find the surface area, so how much paint it would take me to cover this whole shape here, then I got to deal with finding that circle also.
I'm still confused on how it cuts out 4 equal circles.
Go on, what'd I tell
Yeah, me too.
you? Go home and figure it out. Next, cones. Look for the surface area of a cone. Surface area of a cone. It's right here, right? Bottom of the 3rd page. Bottom of the next to last page. You probably, this is the one where Hunter wants to perk up right here, because cone and pyramids are the ones that's going to confuse everybody. For a cone, for surface area, it's got 2 different formulas. It's got that one, leaving off the or, and it's got this one. Probably want to write down on this, you want to use this formula if you know R and S. So if you know R and S, you use that formula. If you know R and H, use this formula. And I'm going to explain what all those are. So if I have a cone, this is my cone. All right? What's the base of a cone? A circle. On that circle, the one thing that you need to know every single time is you need to know the radius of that circle. So R is the radius of the base. Gotta know that every single time for whichever formula.
Does the S stand for stand height?
Sort of. S stands for slant height.
Oh, I couldn't bring up on that.
Slant height. Now listen closely because you're going to get slant height and regular height confused. Slant height, if I'm holding this cone right like this and I slide down the side of it, that's the slant height.
Alright.
That's the slant height on the outside of the cone. That's the slant height. So this right here is the slant height. You might want to draw that cone and label it slant height. Or is there a cone already on your thing there? There's not a picture, is there?
No.
But
I drew it.
so draw it and write in. That's the slant height.
And then H just stands for height.
H is just the height. So on this one, the H stands for height. And I'm even going to write this just in parentheses. The height going down the middle.
So that's the vertex of the radius.
So, right, so it's vertex to the center point. So if we were standing on top of this cone, Silas is up here at the top, I'm down here inside the cone, and he's trying to help me get out. He's going to drop me a rope. That rope's going to fall because of gravity right down to the center point of that cone. That line or that segment that rope makes, that's your height. So that's just the normal height. You got two different heights in a cone. You got a normal height and you have a slant height. If you know the slant height, you can use this formula. If you know the normal height, you can use this formula. Now, maybe Natalie's looking at this one and she's saying, but I don't like that formula. And that's fine. You really don't ever have to use this formula because as I traced all this, what did I form right there? Triangle. Not only is it a triangle, but what kind of triangle is it? It's a right triangle. This is our slant height. This is our normal height. This is our radius. We're going to have to know the radius just about every time, or we're going to have to find it. Okay? We're going to know two of these just about every single time, unless maybe they give us an angle. Like they give us an angle and tell us this angle right here is 50 degrees. Then we can use SOHCAHTOA to find some of the others. But what if I gave you this, and let's say I told you this radius was 3, this height right here was 4, and Natalie doesn't like to use this formula, so she wants to know the slant height. What's that slant height right there going to be? 5. It fits in
3, 4, 5.
fits in that 3, 4, 5 family. Right? It fits into that family, and I'll guarantee when we take this test next time, there's going to be some of them that you could use that on. So make sure you remember those. 3, 4, 5, 5, 12, 13, 8, 15, 17. Now, could she use this formula for surface area rather than using this longer formula? Yeah, because now she knows the radius and she knows the slant height. If it doesn't bother you, have the longer formula, because the calculator is going to do most all of it for you anyway. You could punch all this right into your calculator and it'll do it all as one thing, as long as you don't forget a parenthesis somewhere or something. It'll do it all for you. All you got to do is punch in. So if I was going to put this in on this one, now knowing the slant height, I could just punch in right into my calculator. I put pi times, what's our radius on 3 squared plus pi times, what's the radius again? 3 times the slant height is 5. You punch all that in, it'd give you the answer. If I wanted to use this formula, it'd be pi times radius is 3 squared plus pi times radius times, and then I'd have to put square root, and then I'd probably end up have to put a parenthesis. R squared, what's the radius this time? Oops, I don't know why I put an R there. That should be a 3 out there, right? So 3 squared plus, what's the normal height? 4 squared, close the parenthesis. You plug all that into your calculator, either way it's going to give you the same answer. For volume, flip over to the back page. For volume, volume of a cone, it's right here. We got 1/3 times pi times radius squared times height. This time you actually need the normal height. You can't use the slant height for volume. So if they tell you the slant height, you're still going to have to find the normal height if you're looking for the volume. So you have to have the regular height. This cannot be, again, write this down maybe on there, can't use slant height. And I hope everybody's listening closely, because I'm afraid that maybe I'm going to have 1 or 2 of you that says, well, you told us never to use the slant height. No, you can't use the slant height on the what? Volume. Not the surface area. Can't use the slant height on the volume. In this, you might want to rewrite this formula. Might be a little easier, because then you could just plug it into your calculator all at once. Instead of 1/3 times pi times radius squared times h, you might write it down like this. Pi times radius squared times h divided by what? 3. So maybe rewrite it that way on your paper. And then all you're going to do, you're going to punch all this top in. Pi times radius squared times h, hit equals, and then hit divided by 3, and that's going to give you the volume. That might be a little easier than dealing with the fraction, the 1/3 there. The last one, a pyramid. With a pyramid, to name a pyramid, you're going to do this. The base plus pyramid, just like with a prism. If I have this pyramid, we look at the base. What kind of shape is the base?
Square.
So it's a square pyramid. It's that simple. It's a square pyramid. You don't even have to add on the gonal or nothing like that. Square pyramid. If I had this pyramid, watch how great of a drawer I am here. Just like to show off my talents. If I have that pyramid, what kind of pyramid is it? Pentagonal. Now that we do have that.
Okay.
Oh, yeah. So pentagonal pyramid. All right. On this, for surface area, we got to find the face, or all the faces, and add them up. So if I'm looking at the one I have in my hand here, we have a what? Square. We're going to find the area of that square, and then we also have what other shapes? Triangles. How many triangles? 4. Now in a square pyramid, what's true about all 4 of those triangles? They're all the same. If this is a regular pentagon down here, then what's true about all those triangles? They're all the same. If it's a rectangular pyramid, are all the faces the same? Are all the triangles the same? No, we have to find them each separate. But, again, for this, you're going to have you're going to have one base. You're going to have one base instead of two like in a prism. And then you're also going to have, the rest are going to be triangles. One base and the rest are triangles. Always in a pyramid. You got one base and the rest of the faces are triangles. What kind of shape do I have down here? Hexagonal pyramid. Alright? When we're doing volume, let's go back to surface area. When we're doing surface area, you've got to, again, be able to find the slant height, because to find the area of this triangle right here, we need that height going down the side of the pyramid. We don't want the height going down through the middle of the pyramid. We want the height going down the side for surface area. Okay? For volume, all you do is 1/3 times big B times H. What's big B stand for again? Area of the base. Which one's the base on mine that I have in my hand?
Square.
The square. So we find the area of the square, times it by the height, and then maybe a better way to write this one, you might want to write this down, instead of 1/3 times big B times H, we could change it to big B times H divided by what?
3.
3. So that might be an easier way. So I'd find the area of this square, times it by the height. Remember, the height's going to be Silas up here, me down inside the pyramid, and him dropping me a rope. That's your normal height. This is your slant height on the side. Don't get normal height and slant height confused. Everybody think they can handle all those?
Yeah.
We got about 20 minutes, not quite 20 minutes. I will work some of these problems for you. So take a minute or so, look through there, and let's not start off with the hardest problem on the whole packet. Let's try to start off with one that's not just going to confuse everybody right off the bat. So when you find one that you want to see, look through there. Don't care about your phone case, Bobby.
It looks like
On. Shh. Which one?
I like number 10.
Number 10. Number 10.
Gotta get it out of it. Yeah.
Gunner.
No, because I get up when he yells.
Gunner. Gunner. Set up, get the hood off. I'll let you sleep, I don't care, that's up to you. But you're not gonna put the hood on your head and everything.
Dang, bro. You ain't got those red bodies going on, brother.
Number 10, what kind of shape do we have? Close. Pentagonal prism? Is that prism?
No, pyramid.
Pyramid. Shh. I want to ask again. If you're not talking about what we're talking about up here, you need to shut up. So we got a pentagonal pyramid. We want to find the surface area and the volume. First, we're going to start off with the surface area, then we'll do the volume. Do we have a formula for a pentagonal pyramid for surface area? Look on your formulas worksheet.
So,
There's not one? What do you have to do?
find all the shapes.
All right, you got to find the area of each face and add them all up. What faces are we going to have on this one?
A triangle.
One triangle?
No, 5
5 triangles. Now, what do we know about those 5 triangles?
All the same.
They're all the same in this case because the pentagon is regular, right? So we got 5 triangles. What other shape?
Pentagon.
Pentagon. So what's the formula for area of a triangle?
Base times height, half.
Half a base times height, right? Make sure you know all these formulas. Look them up on your packet there. So looking at the triangle, we need a base and a height. How are we going to find the base and the height?
Slant height.
The slant height is the height of the triangle, right?
23.
So it's 23. So that's the height. What's the base?
14.
14. Does everybody agree with that?
Yes.
And we take that times 1/2. Somebody do all that on their calculator.
Okay.
1/2 times 14 times 23.
I got 161.
161. So what's the area of this triangle?
161.
How about this one?
161.
All of them are that, right?
Yeah.
Gotta be able to do this on the test. Now, what's the formula for area of that pentagon?
Half times P times A.
What's P stand for?
Perimeter.
Perimeter. So we got 1/2 times, what is the perimeter of the pentagon?
70.
70, everybody agree with that?
Yep.
How do you get 70?
14 times 5.
14 times 5.
Then is 9.63.
The apothem, that's the A, is 9.63. Somebody do all that on their calculator for me.
Three.
337.5 hundredths.
So 0.1 we'll say, is that close enough?
I know how he got 5, but where did he plug it into?
5.
He said 5.
Oh, the 0.5?
Okay, never mind.
So 0.5 times 70 times, is that what you?
Yeah,
I didn't point five
misunderstood.
times.
Oh. Oh, you might have been talking about 2, he said 5. We knew one of these sides was 14, right?
Yeah.
To find the perimeter, it's got 5 sides, right?
Okay.
So you take that 14 times 5 and gets up, that's probably what you were talking about.
Yeah.
Is that something different? Everybody get that for that?
Yeah.
Now what do we do with all those?
Add them all up.
Add them all up. What? 1,142. Anybody else get that?
Point one.
0.1. What's our units?
Inches.
Which one is it?
Inches.
Inches squared. Don't forget your units. You're going to be pretty upset when you get your test back if you miss a whole bunch of problems because you forget your units. Volume. Look up on your formulas packet, what's the formula for volume of a pentagonal pyramid?
The other
There's
prism.
a pyramid.
Base times.
Not prisms. We're not doing prisms.
Pyramid is V equals BH divided by 3.
B times H divided by
3.
3. Everybody agree with that?
Yeah.
Right? B stands for the base.
337.
So it's that one, right? So it's 337.1 times, here you gotta be careful.
Gotta find height.
The height, if I have this, do we know the height?
No, but we
No.
just use A squared plus B squared.
You use Pythagorean's theorem, right? Watch again. Remember, these that I'm drawing, down through here, down on through the side, that's the slant height. We want the height going directly down through the middle and making a right angle right in the middle of the shape. That's the actual height. Right? And Matt said we could use Pythagorean's theorem. We have this triangle here. If you drew it down through there and you connected it over to the other side, we know that this part here is how much? The slant height is how much?
23.
23. What's the apothem?
14.
9.63 is the apothem, right? And now could we find this?
Yeah.
Yeah, make that our x. Tell me how to set up Pythagorean's theorem.
9.63.
9.63
Squared.
squared plus
X squared.
Well, yeah,
x squared.
equals 23.
You can do it this way. Just try to make it as easy as possible on yourself. Do 23 squared on your calculator. And then what are you gonna subtract off?
9.6.
Minus 9.63 squared. And then you end up with x squared equals whatever that number is. Well, what do you gotta do to that number? Take the square root. Somebody tell me what was that number when you subtracted those two?
Oh, 463.36 or 36.
And then we wanna take the square root, right? What's the square root of that 463 number?
20.889.
So about 20.9. That's our height then. So what goes in right here? 20.9. And then we multiply those two together, then what do we do with that answer?
You times it. Oh, you divide by 3.
Divide by 3.
2,348.46.
That's just.
Into
2,300 and what?
48.46.
So about 0.5.
Yeah.
What's our units?
Inches cubed.
Inches cubed. Surface area, volume.
Can we do number 18?
Number 18.
What? Well, I know it's that part's easy, but what is that thing on top?
That's a
Hemisphere.
The who? So it's a cube hemisphere? Makes no sense.
We spent like 20 minutes talking.
I just don't.
So number 18, we have something that looks like that, right?
Yeah.
When we're doing the surface area, what are we going to have to find the surface area of?
Cube.
Cube, is that a cube?
That's a.
Rectangular.
It's a rectangular prism, isn't it? It's not a cube. Rectangular prism plus, what other shape? Half a sphere.
That's it. You know,
Now, you got to remember on this one, we talked about this a few minutes ago. Do I want to find the area of that circle this time?
no.
No, because it's not part of the surface area, so we don't have to worry about it this time, right? If it was just the half a sphere all by itself, then I'd have to worry about it. But this time it's sitting on something, so we really don't need it.
You gotta subtract it from the.
We are going to have to subtract it from here, though, aren't we?
Yeah.
So we're going to subtract the area of the circle from that rectangular prism. So for a rectangular prism, how many faces does a rectangular prism have? 6. So we got 6 rectangles. But one of them, we're going to subtract off the area of the circle. Let's find the area of the circle first. Pi times, what's the radius of our
3.
circle? How'd you get 3?
6
divided by
6 divided by 2. Somebody be ready to find that here in a minute, and we'll take care of that.
For what? Circle or the. Here.
Yeah,
I got it.
either one. Same thing.
Uh,
So on this, what's this face of, let's do the bottom. What's the bottom face of the rectangular prism? What by what?
6 by 10.
6 by 10. What's the area there?
60.
60. The next one is 6 by, or the top is 6 by 10 also, right?
Yeah.
That's 60, but we want to subtract this off.
Alright.
So do 60 minus pi times, what is 3 squared?
28.27.
That's all 28.27?
Yeah.
Subtract that from 60, and what's that give you?
31.70.
31.7?
Yeah.
So we don't want the 60, we just want that part right there, because the hemisphere, that half the sphere is covering up part of it, and it's not going to be on the surface. Let's do this front face here. What's the dimensions of it?
6 and 6.
6 and 6. What's that area?
36.
What's the back side that we can't see?
6 and 6.
Which is 36. How about the dimensions of this face?
6 and 10.
6 and 10, which is 60. How about the one we can't see on that side?
6 and 10. 6.
And so we have all that, but we still have to find the surface area of what?
Sphere. Hemisphere.
The hemisphere, half of it, right? What's the formula to find the area of a sphere? The surface area of a sphere.
4 pi r squared.
4 times pi times r squared, is that right?
Yeah.
Now, we only want half of it. What could you do to this formula?
2.
Instead of multiplying by 4 out here, we could just multiply by 2. So on your calculator, you're just going to punch in 2 times pi times, what's the radius? You told me once before. 3 squared. Punch that into your calculator. That's going to tell you the surface area of that sphere sitting on top of that shape.
56.54.
So 56.5, we'll say. What do we do with all of those? Add them all up.
400.2.
400.2. Everybody in agreement?
No, better check that, but I'm pretty sure.
Hoping they're checking it.
Okay, yeah, I'm giving up. I did it. I tell you.
368.5.
Wait, let me do it.
You add 31.7.
340.
Yeah, if she got more than you guys, I'm guessing what she didn't do was she added in the 60
I got
and didn't take off that part. What'd you get?
160.
Yeah, you're right. I added
160?
60 and 37.
What'd you guys get?
Wait a second. I did something else.
I got 340.
Where'd you get 160 in, man?
Because 60 times 3, because all those sides, then plus the 36,
Hold on.
plus the
Let me
36,
restart
plus
this.
the 31.
That's already 180 with just the 60.
Just the 60s, 180.
I got
340.2. That's right.
300 and what?
40.2.
340.2. Make sure, go back and figure it out.
I got that too.
340.2. What's our units?
Centimeters squared.
Centimeters squared, because we're dealing with area, surface area.
That better probably have some hit lines.
Remember, you got rid of this. Don't add that 60 in. But we did add that in because that's this part up here that's not covered by the sphere, right? Volume. How are we going to find the volume of this?
Length times width times height.
All right, so for the rectangular prism, it's just length times width times height
This
plus half the what?
sphere.
Half the sphere. We'll need that formula here in a second. What's the length, the width, and the height?
3,
6, 6, and
10.
10.
360.
360.
That's 360. Plus, what's the formula for a sphere?
4 divided by 3.
VS, wait,
For volume.
Yeah. 4 divided by 3. 9. Radius 3.
Radius what?
Cube.
Cube. That way. So plug all that in and you should be able to find that. Next time, there's 2 videos online. One for this one, then there's, oh, don't go, stay. Grab this. There's a pre-test. This will help you study for the test. There's a video online, actually 2 videos, I separated, that goes through how to do these problems. Yep. Do both of them. Try them both. Assignment tonight, 2 packets. This one and another one. Now listen to me. There's 2 videos. Video for this one online. Actually, there's 3 videos. Then there's a video for the other one, but it's split into 2 parts. And it's called the pre-test video 1 and video 2. So you can watch those and they'll help through a whole bunch of this. Pointer options, pin. Number 2, you said, right? We got a sphere. That's my sphere. Radius on this one is 6.9, is that right?
Yeah.
Somebody help me out. What's the formula for surface area of a sphere? 4 pi r squared. Going back to poor Miles back here, his head's about to explode still on the 4 things, right?
Yeah.
No, he's figured it out now. He doesn't-
I just
moved on. What's the radius this time?
6.9.
6.9 squared. You punch all that right into your calculator. 4 times pi times 6.9 squared. So punch it in. 5 what?
5.9. I got 5.9.
598.
597.9.
No, I still have 98.2.
So try it again. 598.2. Is that what we're going with? 598.2. What's our units? Meters squared. That's our surface area. That's our surface area.
My bad.
Volume. That's why we want to do it twice, right, Mallory? To make sure.
But it was off by like something.
Volume. What's the formula for volume of a sphere?
1 times pi times radius divided by 3.
4 times pi times radius to the third power divided by 3. Is that right? What goes in place of radius this time?
6.9.
So you got 4 times pi times 6.9. Now when I do this, because it's too hard for me to punch in on the calculator, that little caret and stuff to do to the third power. So instead of putting 6.9 to the third power, I put 6.9 times 6.9 times 6.9. Just punch it in. You can do the little caret thing if you like.
I got 4,128.
Once you get that answer, what are you going to do to it? Divide it by 3. Somebody give me the final answer.
1,376.1.
1,376.1.
Yep.
Everybody agree with that?
Cube.
Meters cubed.
I forgot.
Make sure you don't forget to divide by 3. If you forget to divide by 3, is it going to give you the wrong answer? Yeah. All right, now pick me a different one.
Number
14.
Number 3?
14.
14? Do we need to take a vote?
14.
Let's do 14, then maybe we'll go back to 3 if we have time, if we hurry. 14. What kind of shapes do we have in 14? All right, a half of a sphere is actually called a hemisphere, just like the Earth. It's called a hemisphere, and we have a cone. We know that this height, and I'm not sure why they gave it to you outside this time, that's 5 centimeters. The height that they put out here, I'm not going to put it out here, I'm going to put it right here because that's what it is, and it is 12 centimeters. Could we find this slant height before we ever start doing anything else? Yeah. Now, another thing I'm going to tell you, make sure you know those. What's this hypotenuse going to be in that right triangle right there? 13. We don't even have to do a whole lot. Didn't have to do Pythagorean theorem. You just use the 5, 12, 13. Guarantee I put some of those on the test to make it easier on you. Right? If you know those families or those triples. So surface area. What do we find the surface area of? The cone. So help me out. What's the formula for surface area of a cone?
Pi r squared plus pi rs.
What is the radius this time? 5. So 5 squared plus, what's the radius again? 5. What's the slant height?
13.
Plug all of that right into your calculator. That's a 5 there, not an S. Plug all that right into your calculator. It'll do it all for you. Anybody else get that? Now that's the cone. Oh, I'm sorry. I messed you up here. How'd I mess you up?
Oh, you did this.
Oh, you got the bottom circle. You got
We're looking at this cone right here. And when Daniel's trying to touch it again, what's he not going to be able to touch? He's not going to be able to touch that circle, is he? So we got to subtract which part of this is the circle? The pi r squared. So we want to get rid of this. So now let's go back, just do that part. That's all we want this time for the cone. 200 and what? 204.2. Now, what's the other thing that we got to find the surface area of?
This here,
So we're going to do the sphere. So what are we going to do?
cut it in half.
We're going to do the sphere. So we don't want the whole sphere. We only want the hemisphere, half of it, right? Now you got to be careful because sometimes with the hemisphere, what are you going to have to add on? You're going to have to add on a circle because that's not part of the surface area, right? But this time, is that circle part of the surface area? No, so we don't have to worry about it. So we want half of, what's the formula for a sphere for the surface area? Oops, 4 times pi times r squared. What's the easiest way to do that before we ever start punching it in our calculator? What's half of 4?
2.
So we can just do 2 times pi. What's the radius this time?
5.
What is 5 squared?
25.
So just do 2 times pi times 25.
157.1.
Now you got that answer in your calculator. What do we need to add to it?
That.
That. So just add that to it.
361.3.
Anybody else get that?
Yep.
What's our units?
Centimeters squared.
Centimeters squared. However you do these, there's a million different ways to do them. You do them however it's easiest for you. For volume, what am I going to have to do?
Well, you got to do
Volume of the cone plus what?
volume of the hemisphere.
Half of a sphere. So you just do the volume for one, volume for the sphere, take half of that, add those two together, and that's going to give you your answer. 575?
That's right.
575, is that your final answer?
0.96.
Oh, 0.96 centimeters cubed.
I don't know.
Before you go anywhere, you're not sure about your answer?
It probably be exact. It's not right.
Don't go anywhere. What, I can't find them. Maddie's got them. Again, online, there's a video for this pre-test. Get on there, watch it. Shouldn't be real difficult. There's actually 2 videos for this. There'll also be a video for all this stuff. Grab one of these before you go. Try to do as much as you can of both packets. Test next time. Over areas, perimeters, surface areas, volume. You can use the formula packet on the test.
Okay.
Yes, sir. Oh, where are you going to right now? Will you do me a favor? We dropped those off down in the ISD room. I'd hate to see Mason not above the library there. Hate to see Mason not to be able to do his homework.
Where?
In the library,
Yeah,
those
the
ones right
library.
at the top.
You know you.
I know he ain't gonna do it. I was just being sarcastic. So next year, do me a favor, because maybe this will detour some people next year. As you guys are walking into Algebra 2, and you see him walking into Geometry in, whichever. You see him walking in there, go. Don't have to say anything, just sticker and point.
Because he's still coming in the geometry.
Right. Probably still be coming in Algebra.